I'd better share a screen here. Just a moment. Okay, so um, so we're going to talk here about the relationship between knot theory and diagrammatics and cybernetics. And what I thought I would do it rather than use a slideshow, although I may reach into some slideshows that I have available here. Oops, excuse me. I was just wanting to move um, something to make it easily available there. Rather than use a slideshow, I'm going to use my Blackboard and talk about some things, and I hope that they will raise some questions for you so that you can ask them, and we'll see how this goes. I hope that this turns into a conversation. But I want to begin by reminding you that the background of this is not theory per se, but maybe the notion of distinction on the one hand, and the use of diagrams that are ubiquitous in cybernetics, and to think about what is going on with that. So, for example, if you were to open um, a paper by Stafford Beer from a while back, you would see some diagrams. And I chose this because these are about as simple an example of diagrams in cybernetics as I can think of. Look at this one, figure 1, basic homeostat connecting a control system to a world situation. And and all that's been done is to indicate a feedback loop. But then on the other hand, you know that from the point of view of someone like Beer, the idea is to take that idea in as large a chunk as is possible. He's thinking of an entire world situation, maybe the government of Chile, maybe something larger than that, and trying to divide it into what the relevant feedbacks are that will be important for that. And then the diagrams become a way of articulating something about that, possibly metaphorical, possibly very concrete.
May I
Another,
interrupt
yes,
with a question?
sure.
Can you go back to the figure? Yes. So my introduction to this figure, which is exactly the same geometric form with in turn exactly the same arrows, direction of the arrows, came from the work of Robert Rosen, and where he employed the notion of a category on the left-hand side being a living organism, and on the right-hand side, the logical analysis of that organism in terms of various, he uses state theory. So that, well, this interpretation that you give of the same diagram is given a completely different
Sure,
interpretation.
and this is an earlier one. This goes right back to the very beginnings of cybernetics, the idea of looking at the fundamental feedback loop in some situation and trying to divide the world of that situation into a part that could be regarded as the significant controlling factor in the feedback loop.
Yes, but to continue,
Mm-hmm.
for Jason's comments that we had just before you came on, this sort of diagram can be equally applicable to any scale of system or any way you choose to conceptualize the two symbols represented by the system and the control processes.
Indeed.
And so that's the essence of the generality of this figure, and it does not depend on the scale of the language involved.
Oh, that's interesting. The scale of the language involved. You use the term the scale of the language involved, meaning what? Meaning the reference of the language. We might be referring to something as simple as a thermostat in your house or we might be referring to the entire world. Is that what you mean by the scale of the language, or do you mean something
Yes.
else? That's
No.
what you mean.
Okay. But to pursue that further, in my talk yesterday that I gave, that Jason did not, I don't know how much of it Jason saw, but
Mhm.
the scaling of these languages is, with respect to the diagram, depends on how you choose to use the number systems as meaning of units. So if you choose to use units of thermostats to interpret the diagram, or you could choose to use units of cells, biological cells, or human individuals. So the
Yeah,
scale of
right, right. So there is often a sense of what are the units involved, right?
yeah, and so that
Mhm.
was a critical point I wanted to point out for Jason's, to continue my conversation with
My,
Jason.
my, my
We started on.
understanding, my understanding is when you say scale, you actually mean the category of the fields, like
Yes,
chemistry versus biology versus psychology, things like that.
yeah, yes, or
Okay.
consciousness, or and so what this means then to me, Jason, is
Mm.
that the mental image that I draw or that I construct for myself, okay, depends on which language I choose to invoke.
But Lou is going to tell us something in topology, so
Yeah,
it's
right.
the
Well, that's it,
abstract.
and that's another kind of language, and we're going to talk about how topological language might be useful here, right?
Exactly,
Hmm.
exactly.
Yeah,
Okay, okay.
right. And one more diagram from this paper, and of course you've seen lots of diagrams of this kind, but this is a nice example of it becoming a little more complicated, right? Um, Here it's a biological diagram, and he's talking about euglena, and he's talking about how they interrelate with one another, inhibition, sensory, and so on. Uh, and um, and the other, of course, striking thing about diagrams coming from Mr. Beer is that they all have a kind of interesting aesthetic quality that suggests something to you beyond the words. I think that's interesting.
Is this the same thing with Roche-Aspie's homeostat? The Roche-Aspie's little turtle thing?
I'm sorry, what are you referring
I
to?
mean, this thing, euglena. Uh,
Euglena is a one-celled organism.
okay,
Yeah,
one cell organism.
yeah, a little organism. Um, yeah, so so
Could you give your interpretation of the arrows in this diagram and the dots?
um, well, as you see, if you look at it, he is in fact describing it here. It's interesting to read. This is a photosynthetic free swimming protozoan, um, and it's sensitive to light. The tropism reverses after illumination has reached a critical level. It's sensitive to heat, chemicals, and mechanical shock. So he's talking about the action of the metabolism of the euglena within its environment. And I hadn't thought really carefully about exactly what the pathways mean in this diagram. I don't think we need to worry about it unless you're interested, but I
Oh,
can send you the paper.
well, my point would be that this is exactly the point where the scaling of the language is
Yeah, this is a very
critical.
good example of the scaling of the language because here we're thinking about individual euglena and how they are affecting one another in this space.
But you also concerned about the scaling with respect to the nature of what are the causal impacts or the causal relations associated with these different languages.
Yes, exactly.
So he's dealing with light, which I presume
Yeah.
would be electromagnetic radiation.
Yeah,
And
very good. You're dealing with light. You're dealing with how light, which has its own levels of language, which, if you're going to be a physicist, is a very different scale of speaking. If you're thinking
exactly
about the
my point.
photons, and the euglena, and And if photosynthesis is involved, then you really have to think about the structure of the light in the sense of the packets of energy of the light are involved in the photosynthesis. So it can get quite complicated.
But you also must include that, well, it's photosynthesis, therefore the chemistry that is developed around this involves the chemical transformation necessary for metabolism.
That's right. That's
And
right.
so which of those arrows respond to which scale of language?
Right, and you see that he's chosen certain levels in order to emphasize them in his diagram. He's talking about the fact that light and inhibition are related, and those are the themes that he's working with here.
And I
So
noticed,
yeah, so it isn't a complete diagramming of the euglena, but on the other hand, and their interactions. But on the other hand, if someone wanted to make a more detailed, with more levels diagram, this could be the header for it, the large scale picture.
Lou, I just noticed, I would love to see this paper. I just noticed when you were scrolling down, there's a mention of ponds. So in other words, the euglena are in an environment.
That's right too, and the diagram doesn't show you much about the ponds. You don't see any ponds in this picture.
Well, this is a metaphor I'm working with very
Mhm.
presently around ephemeral ponds. So I would love to see the paper.
Sure. I could put this paper in the chat line right now.
Thank you.
Just for the sake of this, just a moment. Let me unshare and
Yeah.
put something into chat.
Thank you. And also, Lou, just for the quality of Jason's video, you might want to adjust your camera because we're not seeing your full
Oh,
face. There we
sorry.
go. Oh, look
Yeah.
at that.
Yeah, that's easily done. I'm looking for chat here. Where is chat? There it is.
Thank you.
Okay, now I can put this into chat line for you. It's a paper called it's called Cybernetic Fabric. Transfer is restricted by your account administrator. Dear account administrator, who must be Jason, has to give me permission to transfer. If you make me a
How do I
co-host,
do that? Don't know.
well, make me a co-host, and we'll see if that works.
And how do I make you add a participant, right?
You go
Yeah.
go to me and
And
you can probably
Hover
make
over.
co-host.
Yeah, there you go.
Yes.
all right, let's see if that works. Oop. If it doesn't, I'd put it in the email to you later. Yeah, there's
What?
some restriction on transferring files. So I'll give you these files. I'll send these files to Jason later and he can distribute them.
Okay.
Yeah, and the metaphor of fabric, I think, is fascinating also.
Yes. Mm-hmm.
It's
As long as we're
absolutely
oh,
crucial.
you saw the other beer paper which said cybernetic fabric, right? Is that what you were reacting
Yeah.
to?
Yeah.
As long as we're talking about beer, I will show you that other paper. It's actually a great deal of fun. Oop, there we go. We're back. And you can see me okay now? I'm not,
Yes.
yeah. All right. This is not an ordinary beer paper. Oop, I got the wrong one there. Oh, I'm sorry. That's the one. It's called Cybernetic Fabric. But as long as we're talking about beer, I'm going to show you the other beer paper, which I'll send you. I think he wrote this for his niece.
It's charming.
Let's go through it for fun. It's about the use of diagrams, and it, of course, is very much about his artistry, but it's also about his cybernetics. The whole world is divided in two by a glass window. One side is Kate. What's Kate doing? Kate is showing off the world. On the other side of the glass window is the rest of the world. It's a bright spring morning and the rain has stopped. The rain flies about everywhere in sparkling drops under the sun. Now Kate is just thinking. One day, Kate was looking through the glass window and she saw a bird. This is the bird. I don't know what sort of bird this is. I'm not very good at birds. It looks a bit like an eagle and a bit like a turkey. On the other hand, it looks like a cross between a hawk and a dove. It all depends on how big you are. The theme of scale. Anyway, although I don't know what this bird actually is, I do know his name.
Oh.
His name is Mr. Joe, they fed me all winter. Well, that's what he says. Of course, if you are doing the talking, his name is Mr. Joe, we fed you all winter. At any rate, he is grateful bird because all that feeding, and so he's singing with happiness outside. Now something outside went inside. He'll wake the baby up, Kate thought, from her side of the glass window. The baby, you see, is in the garden. It belongs to the rest of the world, but it seems that the baby is also inside the house, depending on where it is or where it is in Kate's mind. I'm not sure which is which here. You can, of course, bring the baby in if you like. And then the baby is not in the rest of the world anymore. The baby is with you, but on its own as well. You are in the baby's rest of the world.
Oh.
Kate always does things suddenly because she does not give herself time to think. And when Kate calls Mommy, she always yells. Mommy says, Kate, that's because Kate thinks she's deaf, but Kate does not think Mommy is deaf. Kate also knows that Mommy knows that Kate does not think Mommy is deaf. And now he's playing with recursions of language that Kate knows, that Mommy knows, that Kate knows, and so on. Where was I? Oh, yes, Mommy, yelled Kate. There's nothing for me to do. Well, said Mommy to Kate, of course. Your bed is not made, your curtains are not drawn, your books are on the floor, your clothes are in a heap, the light is still on, the goldfish isn't fed, your breakfast is still on the table, your homework isn't done, the rabbit needs cleaning out, you're very dirty, your hair is not combed, your shoes are in the hall, the milk bottle you smashed is still on the porch, there is ink on the carpet, and I could do with some help. Exactly, said Kate. There is nothing whatever for me to do. So Kate went and looked at the bird. The bird was singing again with happiness. I know what I must do to help Mommy, thought Kate. I must stop the bird singing before the baby wakes up. But you can't talk to a bird through a glass window. Kate ran upstairs. I must find some paper and write a letter, she said. But all her paper had gone. It had been stolen by her wicked brothers, she thought. The window was open, though, and the soft spring rain had come in, and on the steady paint of her bedroom windowsill, there were many shining drops of water. These will do fine, said Kate. So Kate wrote very carefully on a drop of water, Dear Joe. But Kate had never really met Mr. They Fed Me All Winter. She had just looked at him singing through the glass window. She knew she could not call him Joe, so she rubbed that out. Well, to speak the truth, she just put her elbows on the raindrop and soaked it up. Kate started on a nice, the boundaries are getting interpenetrating here, what with raindrops and so on, and soaking one thing into another. Kate started on a nice fresh raindrop on her bedroom windowsill. She wrote, Dear Mr. We fed you all winter, and that was more polite. Her letter went on from one raindrop to another. Please stop singing or you will wake up the baby. Just like that. Kate was quite pleased with her letter, which was just one problem. This is a secret. Some diagrams are occurring here. You and I know that the problem, what the problem was, don't we? The problem is this bird singing. Here is this baby sleeping. It's all outside, and Kate is inside with her letter written on drops of water. What can Kate do? It's all right. She has an idea. She hurries off to the bathroom and fetches her sponge. It's dry and quite hard, like a very light brick. The sponge immediately soaks up the water from Kate's windowsill. Her letter is all inside the damp sponge. Kate leans out of the window and the bird is underneath. Guess what she does now? Yes. Kate wrings out the sponge. Her letter has got to the bird after all. The bird is very wet. The bird went away to the other side of the garden. It had got the message, I think. What do you think? And now we have a diagram of that. That's very amusing, right? There is the matter of the perfect continence of the distinction, and he's playing with Spencer Brown's mark here. He knows that. And then he's playing with how you might get across, or that might be possible to get across the perfect continent of the distinction, and then he's drawing diagrams of this and introducing themes of permeability and non-distinctness, wetness, and so on. And remember our secret, it looks like this now, which means there is no secret. The bird knows the secret, it's all wet. I've forgotten how long this is, but we can go on. Anyway, Kate was inside and Mummy was outside. Mummy just put the baby outside, which means the baby was outside the outside of Kate. And of course, the bird was outside all those outsides. You can see that in this picture. Cybernetic diagram. The bird got the message and did something. Looks like the baby woke up. The Kate decided to talk to the bird, and Mummy went outside to push the baby around the garden. Outside all that was the rest of the world, including many things, including the people in Africa and the North Pole. And here we are, changing scale, right? You cannot make a list of the rest of the world, thought Kate, because you would run out of paper and time. Kate was quite right. So Kate said to the bird, look here, mister, we fed you all winter. Why aren't you singing? Because you got me all wet, said the bird. And besides, my name is Mr. They Fed Me All Winter. That's ridiculous, said Kate. They didn't feed you, we fed you. So you ought to call yourself Mr. You Fed Me All Winter. I didn't feed you, said the bird huffily. And now he's playing with the way words shift their meanings as they go back from one speaker to another. Kate was cross. Kate often gets cross when she gets in a muddle. This is getting us nowhere, she said. Quite right, said the bird. Unfortunately, that is just where I was going. But you can't go nowhere, said Kate. Nowhere isn't anywhere. Don't be silly, said the bird. Nowhere is outside the rest of the world. He dipped his beak in Kate's red paint and drew nowhere, RW and X. We're here, he said. X marks the spot. RW is the rest of the world. That's outside. Outside that is nowhere. Then it must be outer space, Kate said to Joe. No, replied Joe. Outer space is something you know, so it belongs to the rest of the world. Well, said Kate, if it's something I don't know, then it doesn't exist. Exactly, said Joe. It doesn't exist, or it wouldn't be nowhere. Kate was now quite excited. That's right, she cried. It would be somewhere. It would be in the rest of the world, said Joe sternly, which is what I said in the first place. Does this remind you of other things? It might. For example, in the Tractatus, Wittgenstein says, seeing the world as a limited whole, that is what is mystical. Yes?
I could make a comment if, you know.
Yeah, go ahead.
Well, first of all, this is a brilliant and entertaining play with language and
Yes,
symbols.
by the way, I interrupt for a moment. I found this, we found this when we visited the Stafford Beer collection of papers in Liverpool a couple of years ago, or maybe it was 6 years ago. I don't know if it's known outside of that collection of papers.
But I would relate it back to the notions of recursion and Spencer Brown.
Yes,
And
of course.
this, yeah, I mean, it's so obvious. But beyond that, I would just point to Jason again. And Jason, this is a set of issues which I was addressing yesterday, and why we must limit our axiological thinking. Okay, and how we symbolize this in diagrams becomes crucial in axiological thinking without delving into the semantics, if you would, and the semiotics involved elsewhere. And this is the way he sets the boundary conditions here is so gorgeous and so clever. I can't help it. Keep laughing about it.
It is.
Yeah, I
It's
agree.
delightful. And now I know people are just so devoted to Stafford beer. I never knew this side though. But I'm struggling with the tension of the phrase a limited whole.
Oh, I went to Wittgenstein, of course, who speaks differently than Stafford Beer. We got a different scale when I quoted Wittgenstein, didn't I? Didn't we? But the theme is similar, right? I mean, you say, oh, well, let's have a nowhere, and then whatever is in the nowhere isn't in the world. So if the world is everything that is the case, or the world is what I can survey, then I'm imagining beyond the world. I'm imagining outside the universe. Well, what do? I don't want to turn it. Maybe I want to turn that into a thing, and maybe I don't.
Lisa, there's another interpretation of that, and that is that where is nowhere? Well, if there's no nowhere,
yes, right.
and so this relates very directly to the problem of zero. And what is zero means. And there's this play here between zero and language, but in such a clever way.
But just I also
Yeah, and I'm sorry, excuse me, I'll just interject, and it reminds us of the situations where, as with language, we don't know how to get outside of language, and yet we habitually and always go in and out of language, and that we can jump out of the language we've produced and make a comment on it, or we can make a comment on our future language. But everything that happens is then, as soon as it comes out of our mouths, language.
yeah. And this for me,
So nowhere is outside language. Can we say that?
Yeah, you could say that, but having said it, what you said is inside language.
Can I say
Play some
something?
music.
but just one second, Ram. This for me is the problem of Western science where we're at now.
Go on.
To offer to a new generation that is questioning, like that just because you don't know it doesn't mean it's not existing. Like I'm thinking of plant intelligence or more than human capabilities of knowing.
That's
you're
related with your definition of existence. How do you define existence?
And for science, you're talking about hypothesizing, right?
Yeah. What is observable?
We are if we're working scientists or imaginative scientists, we may hypothesize a certain thing, but we don't necessarily know if we have good evidence for it. And then, but sometimes another person comes along with good imagination and shows us that our hypothesizing actually is referring to something more actual than we thought. Like Einstein saw that the dust that little particles of pollen in the water were being buffeted around. And by what are they buffeted around? By molecules and atoms, which you can't see. And so he begins to have evidence for atoms, right? But prior to that Brownian motion paper of his, there wasn't any kind of really good evidence about that world of atoms, even though people have been talking about it.
Yeah, I'm just thinking, just in terms of, we are limited by our human organs of perception. There are other ways of knowing that don't translate into language. Yeah.
Yeah, and many people feel that they're in contact with ways of knowing that are outside of science entirely. But then if we become knowledgeable about it in some way, it's turning into science.
Yeah, and this is where I feel the directionality is moving for young scholars. Yeah, awesome. This is delightful.
Let's continue as long as we're reading it.
Can I say something?
Go ahead.
Right in the beginning slide, when you showed Kate and the window and the bird on the outside,
Yeah,
you're assuming that there are only there is just a glass window in between, but the whole paradigm changes if you believe that there is a mapping system that is in between the two of them.
a mapping system.
Yeah.
Well, of course, it begins in the statement. Kate's in the house. She's looking through the window at the bird on the outside, but then, as you say, this is Kate, a conscious being who is mapping patterns from the outside into her way of structuring her thought about the world, just as we do.
Right,
So
but you're assuming
there's a mapping system going on. Yeah.
But you're assuming Kate, the self of Kate is a whole, but the self of Kate itself is a composite of body, brain, and mind. If you keep on looking at it that way, at every point, it's an. I presented a talk to 4 weeks ago at this group, the concept of open system, saying that everything is a network, but the basic entity in a network are two nodes, an observer and your doer, right? Or like I was saying, so something sensation and action, if you think of it as function. So there is always two complementary entities that are getting mapped between each other. So each exists by itself.
Yeah.
So when I talk about body
and that brings us back to Stafford's original diagram of just two entities that are mapping to each other.
No,
you don't have
saying.
to think of one as controlling the other anymore.
No, that is the whole idea of cybernetics, is control and communication in a reciprocal manner that self-organizes itself. And so there is a mapping system in between the two that is self-organizing and helping to map. So that way, one of the system could be continuous, the other one could be discrete. That there is really, you have to segregate the two. Kate and the world have to be separated.
You can segregate the two. You can articulate the distinction you see there, and then.
But that is the open system. That's open system, and that's biology.
Let's continue reading Kate here. Kate was quite excited. That's right. It would be somewhere. It would be in the rest of the world, said Joe sternly, which is what I said in the first place. That's settled then, Kate said firmly. If nowhere doesn't exist, you can't go there. Don't you believe it, answered Joe, and vanished. And here's a picture of a bird that has gone nowhere. That's the end of the essay.
Thank you very much for showing us that. I really appreciate it.
Yeah, I like it very much. We're going to come back to the themes there as well, but I want to show you one other thing, a paper that I like. that you like, probably. The basic paper by Varela Maturana Uribe about autopoiesis. And this paper is about how self-supporting forms could arise and what it would mean to be alive, those questions. And as you know, the idea in this paper is to look at the level or scale of description that says you have a system which is organized in such a way to supply itself with its own parts from an environment, or to supply itself with what it needs from an environment in such a way that it maintains its own structure. But that structure is the structure that can supply itself with its own parts from its own environment, so that it's self-sustaining. And how do such structures arise is, of course, the question, the biologist's question. You see them all over biology. Any organism that's alive is satisfying such a description, but how could such a thing arise? And could it arise from something that wasn't doing that? And so the paper is articulate and very well known, of course. And it has a model in it, and the model is worth looking at. The model says we're going to have very simple models, oversimplified, of course. We're going to have a space, two-dimensional space, of little molecules. The circles are one type of molecule, and the star is another. The star is a catalytic molecule, not autocatalytic yet, but just catalytic. In the presence of the star, the other molecules like to bind with one another, and molecules that are bound with their neighbors are indicated in these diagrams by little boxes around them. So these are bound molecules here, like that, and they happened in the neighborhood of the star. The molecules can jigger, juxtapose, move from one location to a nearby location, back and forth. They do that. They also bind and unbind. When they're in the neighborhood of a catalyst, they become either potential to bind or actually bound. It's still the case that the bonds can break, but they're much more likely to be there. And so now you see what the story will be. You start with an undifferentiated soup of catalysts and molecules, and after a little while, the catalysts tend to be surrounded by some molecules which want to bind, and then after a little while, the catalysts tend to be mostly surrounded by molecules that are bound, and the bounds go in and out, but you find yourself with a little protocell. And because the catalyst is surrounded by the bonding molecules, it tends to stick around in relation to them. It doesn't escape and leave them to fall apart. It tends to be part of the nucleus of the protocell, you might say. And so once this protocell has arisen, it tends to keep itself going from the environment, and so becomes an autopoietic unity. And it wasn't planned exactly. It has its own organization at a scale different from the original scale, which was molecules and local bonding, and catalyst. It came to have a new level of organization at its own scale, promoted by the fact that there is a structure in the environment, the possibility of something being surrounded by something else, an inside and an outside. So this is a hopeful model, in that, or at least to someone who wonders about biology, I think it's a hopeful model, in that you could see how it could happen that that more highly organized entities could arise from from structures at another level, like this happened in the model. And it has to do with, it seems to have to do with space itself. So I wonder, could this happen in three space? I can ask many questions, right? What questions do you ask when you look at this?
I can make a comment here, but before I go directly to this one, I want to ask you a historical question from the previous issue. Don't go back to the old issue, but you noted that the Einstein paper on random motion as being motivated.
Brownian motion. Yeah.
Yeah, right. Brownian motion. That's the word it's looking for. You placed a great historical importance on this paper that somehow establishes the capability, the existence of atoms and molecules for the physical science community.
I believe so.
Because, okay, I mean, I wanted to verify that this was your interpretation of that paper. So thank you.
That is, and I don't think I'm alone in that. It's interesting also thematically, if you think of early Einstein, he did many things. The other thing he did that is a little bit related to that is he realized that light should be quantized in order to explain the way the photoelectric effect works, the way light and plant interact, the way light and electrical system interact,
Sure,
the way energy flows in relation to light.
sure. Okay, but the point that comes up then is that being educated as a chemist myself,
Mhm.
of course, I didn't ever think of interpreting that paper on Brownian motion as of any great significance.
Oh, I see. But then, as a chemist, what do you think of as the key thing that convinces you of the existence of, let's say, molecules?
The existence of molecules, the
Yeah.
1804 paper or 3 paper by Dalton, I think.
Who did what? Tell me. Go ahead.
Well, so this was a summary paper. I could dig out the reference, but in essence, the notion was that he had the names of the different elements, and he had mathematical ratios of the amounts of the.
Oh, you're right. You're right. Of course, and all chemists know this, right? That even though you can't see the molecules directly, the proportionalities that occur in the chemical interactions are supported by the molecular hypothesis.
Exactly. And
Yeah,
so
that's a slightly more indirect but very important point.
okay. So the next step was what he did in this paper was that he drew diagrams of maybe a dozen different molecules with 4 or 5 different types of atoms in them, and demonstrated the diagrammatic differences of how these atoms were attached to one another.
And they had the different atoms had different amounts of possible attachment.
And different patterns of attachment.
Right. And this was before we understood about the electronic orbits and the sharing of electrons, right?
A full century before that.
Yeah.
A century before that. But before that, there was no, well, for example, there was no relationship known between what we call inorganic and organic. And he used all inorganic compounds basically in that way. And what this allowed then was the development of the language of chemistry, of molecules. The language of molecules became then expressed in terms of the ratios of the atoms in these diagrams. So,
No,
so
if
you
they-
try-
Yeah, that's right. So the arithmetic of that was coming in, and we didn't have an understanding yet of how it worked yet.
exactly. It was
And in those same years, in the 1800s, um, Lord Kelvin went deeper in the physical speculation direction, and he asked, well, what are the atoms? What could the atoms be? The atoms out of which these molecules are being formed. And his answer, which was a popular theory at the time, comes to our theme here. His answer was that the atoms must be knotted vortices in the luminiferous ether. So
right.
his scale, his substrate, was the idea that behind everything is this fluidic ether. That was popular then, that idea.
Yes,
And that the fluidic ether, like any fluid, could swirl, but it swirls three-dimensionally. And if it swirls three-dimensionally, it could have three-dimensional vortices in it, and these would be the atoms. And then he had to ask, are they stable?
That's the question I was trying to ask. On this paper, when they discussed the formation of those little patterns here, you're showing, did they discuss how stable such pattern is and how the stability is maintained? I mean,
And
eigenstate the mechanism.
right now, here
Oh.
in the Maturana Varela paper, Uribe and Maturana and Varela, we see that these entities that are happening in the model, they are stable for a very simple reason, right? Because the catalyst is in the proximity or inside the cell, and it keeps causing the bonds to reform, and the environment is full of lots of molecules. So these little cells are stable, and if you wrote the program, you could write a computer program to do this. They'll behave the way we described. But on the other hand, we don't know how to get to other levels here very easily from this model. How would the cells interact with one another? We'll have to do something new to get to a level about that.
So here I would give a chemical interpretation for Jason's view. Jason, this diagram or these diagrams completely ignore the table of elements. They completely ignore chemical thermodynamics. They completely
You're talking about what Maturana Varela Uribe model ignores. It ignores so much that we
Yes.
could regard this model at many different scales if we wanted to. We could think that the catalyst is a certain inspiring intellectual like Marx, and all of these little circles are the people he's talking to.
Yes, I agree completely. You can imagine what everyone wants to about these diagrams. But I'd also like to return to another point, because Lou, I know you're interested in the philosophy of Charles Sanders Peirce. And Charles Sanders Peirce, his writings, he never comes to grips with this distinction between the vortices models of an atom and the Daltonian notion of molecules. And his
you raise an interesting question. I've got my volumes of Carolyn Isley and some other collections of Peirce. I have not gone and looked for what he said about physics like vortices. I don't know if he talked about vortices.
look at there's a paper about 1897 or 98, and it's tied together with his notion of the grammar of the copula, and why he never accepts predicate logic per se, but he does focus. He has several papers on the role of the copula in his view of language, or his view of philosophy, I should say.
Yeah.
Okay, so I would recommend those papers. They're in the original, not in the new volumes of that was come out of the University of Indiana. Anyway,
I'll
that's
see what I
public
can
knowledge.
find, but if you can find passages in Perse about that, and send them over, that would be great. But you see, the theme of the vortex and the demise of the vortex is worth understanding. Of course, we would like to, if we're going to look at knots, think about, well, how to what extent are knots vortices? And I'll talk to you about that.
Good.
On the other hand, the vortex theory died. It died because of Einstein, among other things, because the luminiferous ether, which was the scale at which it was supposed to occur, was discredited, right? People no longer believed in the luminiferous ether after the Michelson-Morley experiment, and after we couldn't detect any motion through it. But of course, we're left with, as you know, if you read popular science, the notion of space and curved space and so on. So that's like a generalized ether. But the vortices in the ether kind of disappeared because of that. And on the other hand, it comes back as string theory, which is more abstract. But it also comes back as phenomena with vortices about which we know more than we did before. And you really can have knotted vortices in fluids. But that's one level of talking about vortex. Another level of talking about vortex is that this is something that swirls upon itself.
Yeah.
Just like the MUV cell swirls upon itself in its two-dimensional space with the help of its catalyst and keeps reconstituting itself in the form of its environment.
And in which then, shall we say, emerges into the notion of chaos and chaotic systems and these sorts of issues. But for Jason, yeah.
But I wanted to say that there is another vortex that got lost, got discovered, and then got lost for a long time. I think cyberneticists would resurrect it in the circularity that they are so interested in. And but that original vortex, which had to get lost almost immediately after it was discovered, was the Russell set. But see, the Russell set is another one of those vortices of language. It is a set that's defined in terms of itself.
I could pursue that, but I wanted to go back to Jason's.
I will go back to that and we'll talk about that. So I can let it go now and you can say what you wanted to say. Go ahead.
Okay, so Jason,
Yes.
the discussion we've had so far this morning with Lou are all the issues that I have carefully avoided in my talk yesterday.
So we we're is this helpful or bad? I mean, why were you
no. Let's
Oh no,
let Lou finish his agenda today because
go ahead.
This is a 3-session course anyway. So
Yeah.
we will let Lou unfold his thinking for us.
Sure. Now, how much more time do we have?
You already spent 1 hour. You have another hour if you like.
Well, we might not use all of it, but let's continue then the discussion for a little while. Let me talk about. Let me show you a vortex. As long as we mentioned the knotted vortex, this will require going to another place here. Do you know how to blow a smoke ring?
Yes.
Have you ever blown a smoke ring?
Many times.
Good. All right. So some fellows, William Irvine and his graduate student, Dustin Kleckner, in 2012, well, of course, they started it a little earlier than that, they decided that they would try to go from the fact that you can make a vortex ring like a smoke ring to making a knotted vortex ring. And they succeeded. And this, you might think, what? In 2012, Kelvin, back in the 1800s, was talking about knotted vortices in a fluid, but no one had ever seen a knotted vortex in a fluid. You were talking about scientific imagination a few minutes ago, right? No one had ever seen a knotted vortex in a fluid until 2012. And they made one. And if I can find the right slides here, I can show you a movie of how, and you might be wondering, how did they make one, right? They cheated. I think I have to show you first the straight vortex before I do the, I'm sorry, I hadn't prepared this, so let me see, vortex. I have a
You have
simple,
another folder named the slideshow.
we'll stick with this one. It's okay. Oh, unknotted. That's what I was looking for. You see, I wanted to first show you how with their experimental setup, they can produce an unknotted vortex. And it's just like blowing a smoke ring. You put your lips in the form of a circle and you blow the smoke through your lips. And the vortexing occurs along the edges of your lips, right? You can do the same thing by taking a circular, a topologically circular framework here and pulling it quickly down in the water. And you pull it down in the water and the vortex will rise up above it like this.
Trifid.
Now you see the beauty of their good equipment, right? They can take high-speed photography of these evolving things. They have a good light system, which lets the vortex appear in the camera. And as you see it very quickly breaks up. But you can make an unknotted vortex ring by that method. And it's just like blowing a smoke ring. It starts out with a loop, like your lips, only it's a physical loop. The cross section is a teardrop with it very tiny at this end and going around like that. So that promotes the vortexing across the edge. So they cheated. They said, let's have a knotted loop. If you have a knotted loop, then the vortex that will occur along the edge will be a knotted vortex. And so it was. And so it is. And there you have a trefoil knot, the simplest knot, with a lot of noise, produced in a fluid. So if you had a knot, you can get a knot, but you really do get a knot. It's independent of the framework that produced it. It would be very interesting to find a way that a knot could be produced from some actions, right? But here at least you can see a real vortex in the fluid. And that's what they did. We can slow that down in the usual way by, yes, there. And then you see the template dropping down, and the water, the vortexing that's occurring near the template is there. This part here is very unstable, but the forward edge gets concentrated. And so after a little while, all that noise, a lot of it dissipates. and you end up with the forward edge floating up. So that's 2012, very long after Kelvin. Knotted vortices actually are happening in the scientific world. Now, maybe they're happening in out there in the world somehow, but no one has seen them otherwise. Question on this?
Well, I guess, first of all, I presume this is the background behind this is a set of partial differential equations.
Oh, yes. What you're seeing here obeys the partial differential equations of fluid flow, certainly.
Navier-Stokes equation.
Navier-Stokes equations will be obeyed here, yes.
Now,
I'm confused.
how
But
do
of course
you make
there are
connection?
I'm sorry.
I mean, how do you make connections from processes like this all the way towards the formation of DNA, stabilized DNA?
These formations could be visualized in the sense of metabolic pathways crossing over to one another.
Yep. Yeah.
Right. But
Leo, I have a question.
yes.
Are you assuming that this whole thing is one solid of revolution? Whatever we are seeing?
What you're looking at is a photograph of the actual experiment,
Right. No, but go ahead. Yeah.
which
what
is
I'm
occurring
saying
in
is
a big vat of water, right? Still water. Yeah.
It's a colloidal solution, right? There are just discrete stuff that are just moving around. There is no cohesive force holding them all together. It's kind of, each one is in a Brownian motion, but not everybody is
But
pulled in.
It's the fluid flow that keeps it together in the form of those water molecules.
In local vicinity. They're doing their own thing within their local vicinity, but
Right,
the
but
total picture looks like
because of the way it got started, the molecules of the water are going around and around the apparent line. They're going around and around it like that. That's the vortexing. Yeah, for example, you've seen vortexing on the surface of water. Everyone has, and you understand that the water is spinning around circularly, right? But this is that's a two-dimensional version. Here, this is a three-dimensional version, and the water is spinning around the bright lines of the three-dimensional vortex. The vortex is where the spinning isn't happening. Right? If you the center of the vortex isn't moving. If you think of a little whirlpool, the water is going around and around in the whirlpool, but the very center of the vortex isn't moving.
Mm-hmm.
So at least we know no water, no life, right? Has to be from water.
Yeah, the importance of water, certainly. Okay. But as long as we're talking about these vortices and their stability, then I'll show you something else. But I don't have a movie of this particular kind of instability. Oops, I have to show you something else. Just a moment.
Elon Musk has a big job to create water in Mars.
There it is. Another scientist, Alexyenko in Russia, does a different experiment. He was inspired to understand the operation of vortices in turbines, And this is a little more like what you've seen before, because if you have water going down the drain, then you have a kind of vortex line going down the drain, one dimensional. And and that's what you're seeing here as this turbine, which is turning around in the plane perpendicular to the way you're looking, like you're in a big turbine and it's turning a lot far above you. And the turbine is wider at the bottom. The turbine space is wider at the bottom than it is at the top. And you get this line of vortex line of water coming on down. This is much easier to produce. Probably sometimes you see things like this exhibited in science museums. But he noticed something very amazing here, and you'll see it happen in a moment. The vortex line comes near itself and interacts with itself and pulls off a bit. You see that? That's a reconnection. And at this level, I don't think people have good differential equation models, because this has to do with scale, as we were talking about. At the scale of the line of the vortex, we can see how it moves, but the vortex is actually made of water molecules, and they can interact with one another, and they're spinning around, and they interact, and they reconnect like that. And you see in the course of the reconnection, filaments from one end to the other occur. And it pulls off a little closed circular vortex. Let's look at another movie of Alex Yanko.
This is what I was saying. It's all local interactions. You can't have a global solution.
You can't have what?
A global solution. It has to be solved locally. Everything is
Yes,
local.
yes.
Well, we're looking at how it interacts with itself locally. You're right.
Yes.
So here's the turbine again. You can see some support structure in the turbine, and you can see how it's wider at the bottom than it is at the top. That width factor is important because the vortex can move up and down a bit, and it does. So here it is. It's turning, and you see that bit went up, up, up. It's going up, and it's underneath here, underneath there, a little bit in back. This is coming around in front. Okay.
So,
And
Lou, from a quantum mechanical perspective, how do you interpret these movements?
well, what we're looking at here is up here in macro world, the molecular motions that are involved here are motions of water molecules, but then the water molecules are involved in systems of forces among them, which go down into the quantum mechanics, of course.
Yeah, but so this is a scaling issue from your perspective, then. To interpret this diagram in terms of quantum mechanics is a scaling issue.
Well, right, but it's very hard to interpret large-scale molecular motions in terms of quantum mechanics.
I agree.
So I don't know that anyone would know how to do that.
I agree. And so that
but we're aware of that.
Well, it's in the question of the form of catalysis by macromolecules working on orbitals of individual substrates. There appears to be some insight into exactly how that happens.
Mm-hmm. And people do try to extend those studies. After all, you go all the way back to, say, the quantum mechanics of the hydrogen atom, and you understand that it has a certain sequence of energy levels for its electrons. And then you can extend that analysis, at least to understand what the energy levels of the electrons in atoms are for the other atoms, and you can deduce the periodic table from quantum mechanics, essentially, right?
No.
In principle, you get the schema of what valences are, what possible interactions there are for the different molecules.
I don't want to go into depth into that argument at this time, But I would say that if you're dealing with isotopically labeled substrates, so in other words, C14 rather than C12,
Mhm.
you can then, or actually also with regard to H3, tritium, as opposed to hydrogen. With certain enzyme reactions, you can make that distinction in the rate of the reaction. So it's not so vague with regard to quantum mechanics as you suggested from in the case.
But the point I'm making is probably the same one you know, which is that you can analyze how hydrogen works, you can analyze how helium works in some detail, but when you get to larger elements, you can't actually work out everything that the quantum mechanics could in principle tell you, but you get an outline of it, and the outline is consistent at least with what we understand about the periodic table and things like that.
Yeah, there
But
is a
but quantum chemists have a whole research field that they're in for since the beginning of quantum mechanics, and they work away at it.
I'm intimately familiar with much of that history. Thank you.
Yeah. Getting back to Alex Yenko's vortex line here, watch what happens. It's getting near itself again in a way that it can interact. See? And it interacted. Now, I don't have the intermediate photos. They weren't in the film, just gone. It's interacted. But now look, now some topology has happened because the little circular thing that was produced is linked with the vortex line. So we actually produce some complex topology in the sense of linking of one thing with another out of the action of reconnection. So global topological things can happen as a result of local things.
This is in the context of gravity and some kind of energy from the top, right?
Well, you're in a big vat, a turbine, and there's a rotation that causes the fluid to
So
rotate
energy is
up
involved.
at the top, turning, and because it's turning, the vortex is coming on down from across down the fluid all the way down to the bottom, and it's
So our second hint,
being maintained by the turning up there.
so our second hint beside the water is that life must emerge from those waterfalls, big waterfalls.
Oh
carrying
well,
a lot of energy.
we're observing it by having light shining on the fluid, but the light shining on the fluid is not disturbing the macroscopic motion of the vortex. The light is not powerful, and the vortex is a big, robust, macroscopic phenomenon. It isn't being disturbed much by the light.
Lou?
Yeah.
Oh, Ram, is this directly related to this? Because I want to go back for a second to the Maturana, Varela, and Urube diagram with the star. When you asked what was missing. You don't
Let
have
me
to go back there.
while you're talking, let me bring the
Okay, you don't have to go back there, but when you asked what was missing, I was thinking the element of time. Because that's a character here, and just relating to scale, bringing it back to a sense of how we describe things, we use logical types. So
wait, let's slow this down a moment. I see I went to a different diagram, but it's the same picture, right? Catalyst linked. But this is happening in time in that in their model, it changes in discrete steps of time, or in a continuous idea of a model, the molecules are moving around, these little molecules are moving around, and they get near enough to one another to bind or to unbind, right? And this is the reason, this is what you're looking at is something that happened after a certain amount of time. So time is certainly present. This didn't suddenly happen from nowhere. This evolved in time.
Right. So does this bring us to another dimension?
Time?
Yes.
Well, yes, it does.
Yeah.
It does. we can think of, we're talking about a process and how something could evolve from a process.
So back to Kate and Joe.
Yeah.
Like we have these minds that sort of make things solid. When we're talking about them, we compare this to this, like a logical type. So it just feels like there's an element, like, again, bringing language in how we try to describe things that are actually moving, or, you know, parts that we don't see or take into account because we can't know quite that way. I'm just curious in terms of when we were talking about levels of scale. It feels like this is, oh, go ahead, Jerry. What do you?
Lisa, you're exactly on point from my perspective. I don't know what Lou would say about it, but from my perspective, you're exactly on point that when you move from one level to another level, you not only change scales, you change the type of language, and you actually change the grammar of the language. And it is necessary that you change the grammar of the language in order to deal with the different types of phenomena that you're observing.
Yeah, and I think English is a particularly challenging one because we have things so divided into subjects and objects, maybe, and don't account for locality. Like, I have an indigenous friend who told me, like, in modern powwow dancing, it's sort of like, wow, when the women dance, there's a different, the women are, you know, traditionally supposed to stay low to the earth, to the ground. There's different levels of language based on how high or low you are.
So there's a different modality when the women are dancing.
Yeah. Yeah. But
And when
into the language.
we
Yeah.
tend to divide up our vision of some complex situation into different levels and types also. For example, here, you could say, well, what's happening is just that the molecules of the water are moving around all at one level in some sense. But we're looking at it and we're saying, but then there are the vortexing patterns, and then the vortexing pattern can interact with itself and do something and change a topology, which is what we saw here, ringed around. And we're talking about now two levels. There is the level of the vortex itself, and then there's the level at which the vortex could interact with itself. And if we're to understand that, we have to go down into the molecular level of the vortex to see what happened there, which we don't understand very well. So, so the way we act as observers in order to tell a tale is related to how we divide things up into levels, and there might be another way to divide it that would be more perspicuous, right?
Yeah, Lou, the way I met Jason was actually through an archiving project, and that sits with me all the time of how are we archiving system science for the next generation to really find the right invitation into this gorgeous work with the limited ways, I think, many scientists still are in and then this level of language. Anyway, it's just a question. Like, I'm constantly asking, how do we tell the story as we're living it?
You mean, how do you draw the map? Research
Yeah,
the map.
maybe. Yeah, or just invite the territory. Yeah.
There is a complication here that is worth bringing up at this point, and that is that the traditional notion of token and type can be extended to the notion of tone and how you locate. And here the emphasis of my words are on the notion of locate, how you locate some system in terms of its token, type, and tone are different if you just make the distinction of type and token. And this is where the different languages come in. That when you switch languages and switch grammars, you go to a new tone. And the metaphor here that I use is the notation used in music. And you might find that useful, Lisa, to think about how the scales relate to one another in a symphonic orchestra.
Yeah, that is helpful because the other thing that's coming through me is this understanding around momentum, continuity of practice, and coherence. So that's something that's useful there. But I'm also thinking in terms of chemical process of solution, dissolution, and resolution. So I feel like we're at a place now where we've had this solutions focus, solutionary response, and now things are dissolving. And that, I guess that's the frame I'm feeling like is the background to where we are now. And again, I mention this in terms of inviting young scholars at this time.
You have such a beautiful consciousness.
But as long as we're talking about type and level, type and level, let's look at the Russell paradox for a moment, so we see that issue in language very starkly. So let me give you a version of Russell paradox. You have a library with books, A, B, and C, let's say. 3 books in your library, no catalog yet. But the idea, the librarian that we hired has an idea, and that is to make a catalog C, and C will also be a book, so that we don't have to put it anywhere except on the shelf of the library. So you have the book A, and then you have book B, and you have book C, and you have the catalog. Very finite. There are only 3 books in my library, but maybe there were 300, right? And the catalog, well, when you open up the catalog and take a look at it and see what it's doing, it's listing books. And C will list all books that do not list themselves. I mean, there are some authors who are so maybe we should include one of those. We'll call it S. There are some authors who are so proud of their own works that even within the work that they wrote, they make a reference to that work. Right? So then the catalog, so the idea is if it's going to list itself, we won't bother to put it in the catalog. So those are the rules of the game. Are you with me? So then we try to make the catalog. So I say C, and what will it be? Well, I'll have to put what's in here, what I could put in here. It turns out that I can't list this one because it lists itself. But A, B, and C are okay, so I can put them in. Their names, of course, the names of them. And then C is a book.
Yeah, in practice, the solution to this is they won't list the C as a book. The C is a huge pile of
But
index
you're
card.
trying to solve it before I've finished defining it, right?
Okay.
And the question is, what about C? If I should put C in, that would be no good, because if I put C in, then C would be listing itself and it wouldn't be allowed in. But if C is not in here, so that's troublesome. On the other hand, if C is not in there, then if I do this, then C is not listing itself, and that seems to say that C should list itself, and I have a problem, right? Now, Jason, you just said that you would solve it by not making C a book. So
No,
solution.
it's in practical, in practice, they use wooden boxes containing index card. And problem solved.
Oh, yeah,
A
no,
wooden
of
box
course,
containing index
yeah,
cards
no, I
is not a
agree.
book.
In practice, catalog, not a book. But some books are catalogs. So it isn't completely crazy to have the catalog be a book, right? But this will certainly solve the problem. That's a type, that's making a different type, that change type.
That's a type
Right.
theory, right?
That's a type theory, change type, that the catalog is just not a book. And then there's no problem about whether the catalog lists itself, since it is out of the category of books, right?
You know, Lou, when you were sharing,
But
Yeah.
wait, let me
Yeah,
finish
okay.
saying. But
Oh.
so this, in a way, is a complete story. This is one of the ways to solve the problem of the catalog, is to
Mhm.
note that we can change type, and this is the type theory.
Mhm.
This really is the type theory. That's how Russell as a set theoretic paradox comes out the same way. We say, oh, we'll just not have Russell's set be a set. We'll call it a class or something else. Go ahead.
Well, when you were sharing the story of Kate and Joe, the bird, it reminded me of The Little Prince, where the little prince asks the astronaut to draw him a sheep, and the astronaut draws a sheep, and the little prince says, no, that's not at all what my sheep looks like. He draws it again, and the little prince says, no, that's not it at all. And then the astronaut draws a box with 3 holes in it. And the little prince says, exactly, how did you know what my sheep looked like? So there's something about,
Now, why is it a box with 3 holes?
because you can imagine that there's a sheep inside it and it's got the holes for breathing. But you don't see the sheep.
Maybe
Jason, I made you
see,
laugh.
see something.
And I also want to say hi to Gerard. You joined us late. I hope you know a little bit. You can catch on, I think. I don't know.
Gerard is always ahead of us.
Yes, even though English is not his first language, yeah.
I don't know if it's in The Little Prince, but this is my picture of a bear climbing a tree.
So Lou, what's the next solution beside the type theory?
Well, we could say that we'll make a new catalog, which has inside it A and B and C and the old catalog. The old catalog is just this one. and then we might feel a little better because but then we'll have to make a new book. So this is a book, it's on the shelf, and this book has the list of A, B, and C, and we'll put it in there. But now we have a new book, and this book is listing these books. So here's the shelf, and we started out with the forbidden S, which talked about itself, and then we also had A, and we had B, and then we had C, and then we had this book, the catalog, the first catalog, which had A, B, and C in it, and then um, and then we uh, and then we said, okay, but now we have these books, and so we'll have to list A and B and C and ABC, and then we'll have to list the book, the new catalog that lists all of them. Sorry, this is getting a little hard to write. ABC, right? And now we have yet another book.
So my opinion is when
And
things
then this
goes-
will go on forever.
yeah,
this
go
will
on
go on
forever,
forever.
so it becomes an entertainment instead of problem solving. I mean, if the type theory can solve the practical issue, like what I said, you put a big wooden box with an index card. So it's not a book, it's just the index of the books. Then people can keep living their life, the life can going on. But if you force people to get into this endless another C1, C2, C3, and C infinity, and what is the point? I mean, what other practical
John,
solutions that you are chasing at?
the point is that we're now verging on a possible recursion. How bad is this recursion, right? But I'm sorry, I just wanted to get a little room on my blackboard. So this recursion is not too bad. If you think about it, it looks like this. I have an empty library, an empty book. And then the next thing I'm going to do is I'm going to put inside my empty book the book. And then I'm going to put inside that book the list of these two books. So I make a new list with these two books inside. And then this is a new one, so I have to list all three of these, and I go on like that, right? So
are you using a pen or are you using a mouse?
I have invented an interesting recursion, right? The next step in the recursion is included in the list that I already made is this is wait, let me draw it and then you'll see what I've drawn, right? Because what I have drawn is actually to take everything prior to it and put it in a box. So then I could draw all of this and put it in a box, and I'll keep on going like that. Maybe somebody would like to use this for something. It's a recursion. Let's look at a simpler recursion, because this one is rather complicated, in fact. I agree. Maybe you want to think about it. But here's another one that leads to a related idea, and that is map and territory. So this is going to be the world. Or a map of the world, but let it be the world, all right? And then we decided inside the world somewhere to put down a map of the world.
Anyway, I don't know what Lou's schedule is.
Okay. So I'm thinking about how I might have a nice map of the world, and I lay it out on my desk carefully. And then the map of the world is inside my world. Okay? I put it somewhere. And I want to make this picture just minimally realistic. It's not correct at this point because the way the world looks is the world as far as we know it is. We have the whole world, and then there's this map of the world, which is right here. But there's nothing inside my map of the world, whereas I know that if I were going to map my world, there would be a map of the world right in here. That's a little better. Now it's a better picture. It's correct, more correct, right? The world has a map of the world inside it, and inside the map of the world is a map of the world. Are you with me? Or against me?
I'm
but
with
this
you.
picture, what?
Yeah. I'm with you in
Okay.
terms of you're saying that smaller map is my map of the world, my experience, my view.
Yeah, it could be my map of the world if you like, because then it has to do with the way we are in relation to the world. I have my little map of the world, but my little map of the world has inside it my map of the world. And then this one at this point is still not quite right. It needs a little map inside it. But having drawn it, this one is not quite right. It needs a little map inside it. And we'll have to do this forever in order to get a correct picture of the world and the map of the world.
Yes, and time. So, right, the recursion.
Oh, and it'll take some time for us to make the whole thing, or you could imagine it happened all at once. It does happen all at once when you stand in between two facing mirrors. Stand in between two facing mirrors and you get the exact phenomenon, right?
Mhm.
And there is a fixed point as well. Way down in there, there is a place where in the world, it's a point in the world, in this big world, there's a point which is exactly the same as the point on the map. So that the map and the territory actually coincide in this one point in infinity down in there.
For a moment, right?
You could say for a moment.
Yeah, Lisa emphasized the time. I think I would like to emphasize the
but it's
space.
best, I agree, it's best to think of this as temporal.
Mhm.
Both time and space are limited. In practical, I'm currently looking at 3 TV screens, and that's my limitation. So inside my screen somewhere, there is a little program named Google Earth. So if I click that, I have my map of the world, and I can zoom in and play with it. But when we have to listen to Lou here, I have to close that to make room. I mean, I have to contribute to this space to Lou's current talk instead of keeping that map. So that map exists somewhere hidden in my computer, but it doesn't matter for current practical issue. So that my point is, what is the problem or issue that type theory cannot handle? That is still engineeringly significant.
But this itself goes beyond the type theory. This says we should think of the map as always having a map inside it, and it'll go on forever. There is the singular point for if it's my map of the world, the singular point is living at the place of my consciousness.
Okay. So what next?
So it's worth thinking about because it's very close to certain kinds of argument, right? My map of the world, the singular point is in fact where I touch the world, even though I was mapping and mapping and mapping, you get to this place where the map and the world actually have to coincide. So if you go beyond just doing a type theory to get rid of this sort of thing, there are some insights and things that are very fascinating to look at if you do it. Furthermore, this fixed point, there is the fixed point, the internal fixed point. This internal fixed point is the one that Charles Sanders Peirce liked to talk about. But if you look at, I'm going to get rid of our more complicated recursion over here. If you look at the external form of boxes within boxes, going on forever, call it B, then you see that there is an external fixed point as well, and that B is identical to B with a box around it. External fixed point. Suddenly it's in a different language. The external fixed point is in a different language. It has to do with describing the mapping process itself. So I think this is a good example of the beginnings of what happens if you let go of that type theory as something which is going to put you in a box and not let you go into a recursion. But the type theory has things to recommend it as well, right?
So Lou, how do you keep yourself from going into recursion all the time?
He enjoys that.
Well, I'm too lazy to do that.
Well, the thing is that how can I put it? I can experience part of what you're saying.
Well, but I'm asking you whether that is a partly satisfying answer, right? It seemed like a flippant answer, but if you say, well, I can think about my thinking, I can think about my thinking about my thinking. I can keep on doing that, at least verbally, but in actuality, my thought doesn't focus beyond one or two levels of that. It gives up. So I seem to be constructed to not be able to do that.
Well, if I had to give a comparison here, I would note that I have faced a similar sort of experience in my own mind, in the concept that because of my training as a biochemist, it became my, shall we say, go-to interpretive base for how I constructed my world. And so that my world map, if I had to go through an analysis of it, it come back to the biochemical foundations of my training and the language that was involved therewith. With Jason, I note from now several years of listening to his and participating in discussions with him, he is a very, very pragmatic man. And so his go-to basis is sort of the pragmatism of Charles Sanders Peirce, but it's also a very practical one that he employs when he's faced with an issue like going to infinite number of recursions. So he's trying to integrate that.
Well,
yeah. So that's the so the issue then becomes the nature of consciousness, And here is where Ram's ideas, I think, are radically different from yours and Jason's and mine in how he views consciousness. But and of course, Gerard is very special here, and he has, I don't know how he works at all. So let me stop there before I say anything else.
Well, Larry, I think,
I mean, we engage in things like this. I can think about myself or I can point at myself, but we don't. And if you have a structure which is pointing at itself, uh, then this is here it is, just like that, spatial. And on the other hand, if it's pointing at itself, then if you're walking along it, you can keep on going, right? And if you keep on going, there's nothing to stop you from keep on going. You just keep on going,
right.
right? Uh, but just because you have a circularity doesn't mean you have to keep on going.
No, but the algorithm, Jerry, I'm thinking of the pause to stop, but the the Netflix algorithm is designed for 7 seconds between when you finish watching one show and it offers you another. And Ram, you could weigh in on that. That's not enough time for you to sort of stop and say, oh, wait a minute, there's that book that I need to read, or the gardening that wants attention, or so there's that recursiveness that is being used, I think, to capture our attention and not put in that mindful pause to find another variety of how we spend our time. So I think that this is, I think it's an important point of the human capacity of mind. Right, I think this is an issue of consciousness because the library I think about is a much bigger one, maybe called the Akashic Record, that everything is being recorded. But
well, let's consider the Akashic Record there,
okay,
where
good.
everything is being recorded. But I'm sorry, I wanted to write that down. Here it's circular, but you don't necessarily have to keep on saying it over and over again, right? It's stable for you. I'm the one who says I. You might say that in conversation. I'm talking, right? You don't have to keep repeating it. So one of the answers to why we don't keep doing this is that we kind of are built in with a rule that says I don't have to keep repeating things. Once is enough. Twice may be enough. But
yeah, and the brain is designed for efficiency, right?
yeah. So there's a rule. Just like in a computer. If I set a computer to doing a recursion, it could go on forever unless I give it a rule that says, do it 5 times. Stop. Right.
And if you gave it the rule consciousness?
Well, the rule with the computer, here's this computer which is going to be doing a recursion and sending things out. But I give the computer a little self-consciousness in the form of it's watching what it's doing, and it's been told that it should do it only 5 times. And so it's watching and counting, and when it gets to 0, it cuts the process off. So when you write computer programs, you do give them a little self-consciousness of what they're doing. It's not very big self-consciousness, but you have them examine themselves, their own operation.
But I'm thinking more of the case when I go into meditation.
Let's look at meditation for a moment. I'm sorry, of course, you're going to say something and I better stop talking. Go ahead.
Simply that if I really focus, at first it was very difficult, but now it's relatively easy to go into a state of meditation where there's no circularity that are occurring in my consciousness. I'm at a stable fixed point, so to speak. And I enjoy that state.
Uh-huh. Uh-huh.
And so
And
that's what I meant by
Right, and we can
That's the
look at the
biological aspect of this.
right. I wanted to look at the instructions involved. Like, so let's take Eckhart Tolle, whom I remember what he says. Okay, he says Eckhart Tolle says for doing meditation, sit quietly, and then you're in the state of until one overcomes you, of course. You're in a waiting state, and then a thought overcomes you, and you say, okay, I'll let go of that thought. And then you're back in waiting for the next thought. Now, waiting for the next thought appears to be a thought itself, but there's no paradox here, right? It's a type theory in a way, the instruction for the meditation. The waiting.
Why do we have to wait? It just emerges.
But you could be kind of not having any particular thought. And then suddenly you're in this dream about the groceries for next week and you let it go. And then it comes again. It keeps coming. The brain works that way. The mind works that way. So when you're in the in-between, you're waiting for the next thought. You can take that as a mantra if you want, waiting for the next thought. It's a thought, but it isn't a paradox, is it? Because, and why isn't it a paradox? I think because you created a little types theory for your practice.
No. In a distributed parallel operating system, there is no waiting. When one entity loses its priority, the next one in the priority list comes up.
Well, but you know that when you do this, if you sit quietly, you might really be quietly for a while, and then, oops, I'm in this complicated dream about this, that, and the other thing, and then the instruction is to let it go.
And noting is different than thinking. It's creating a space and a practice of noticing. And then it might be a thought, it might be a physical sensation, it might be a sense of peace, but it's not necessarily thought. It's just
but here
whatever.
we're actually talking about the thought. You know,
It-
you sit quietly, and the next moment you're off in this complex dream state which just came right up. All sorts of thoughts about one thing or another or a situation, and the instruction for this kind of meditation suggests.
I think
Okay,
both
let it
Ram
go.
said and what
Let it
Lou is
go.
saying. I think both what Ram said and Lou is saying are different from what I was trying to communicate when what I mean by going into a state of meditation.
Go ahead.
And that state of meditation is the absence of anything other than the feelings of my complete body in harmony with itself.
Oh, well, that's fine. But as you're learning to do it, or even as you're doing it, you kind of navigate because you won't always be in such a nice pure state.
No,
Yeah,
but I love it when I'm.
Now, those are the different stages of yoga, and the goal is to try to get there.
Lou, what else on your agenda today that
Ah,
you have
well,
not covered
what?
yet?
Sure. So,
Sorry, I have to leave. Sorry. Bye-bye.
oh yeah, we're at the end.
Yeah,
I
great,
think
great talk.
I just
Great
want to
talk.
make a final comment because we didn't quite get to nodding yet, but so let me just summarize how much nodding we got involved in here. And one of the kinds of things that we got involved in was linking like this. And I'm going to start talking about how in studying knots, we go from the realism of knots, like those knots in rope or knots um, in water, vortices, and so on, to diagrams which can indicate the structure of the knotting, and how these diagrams could be thought of in terms of our cybernetic themes. So that's where we're going to go. We're going to talk about how these kinds of diagrams are related to cybernetic themes, and what it means to move them around, and how that's related to cybernetic themes.
So you are going to cover that
Yeah. So
right?
we'll
Next
start
session.
there next time.
Okay, great.
Mhm.
Thank you.
Thank you so much.
Thank you very much. Lovely conversation.
It's been fun. Entertaining me.
Jason, thank you for inviting Lou. It's really interesting, and thank you for your generosity of devoting 3 sessions to this.
It's not a generosity. It's curiosity.
Oh.
Good. I like that. I like that.
Okay.
I just before we go, I'm just so curious if Gerard has anything he wants to say.
I was late and I know where it's going, but I'm very interested anyway.
Gerald is our
Thank you.
expert for disagreement, but we don't have time to hear his disagreement this time. Please be prepared next time to give Lou some disagreement.
Oh, we can always have some disagreement, sure.
Okay, see you
Okay.
next time.
Bye.